Hello everyone, welcome back to Rare Chem Official. Today we are going to discuss about Lewis concept and types of oxides. If you like this video, please like, share and subscribe. Without delay, let's get started. Lewis acid or cationic species. Vacant d orbital containing species acts as Lewis acid, and central atom has incomplete octet boron, aluminum, magnesium, beryllium. These are acts as Lewis acid. Okay. What is d orbital? What is vacant d orbital containing species? Means let's take one example, PCl5. The atomic number for phosphorus is 15, and the electronic configuration of phosphorus is 1s2, 2s2, 2p6, 3s2, 3p3, 4s0, 3d0. The rule is for vacant d orbital is the principal quantum number of lost electron is equals to the next electron principal quantum number. Here if you observe, the lost electrons enter into the 3p orbital. The next d orbital principal quantum number is 3. So both are equal. So and next rule is the d orbital should be vacant, means 0 electron should be present in the next d orbital. So here 3d0, no electrons in the d orbital. So both rules are applied. See, no, so phosphorus has vacant d orbital, so it acts as electrophile. If take NCl5, atomic number for nitrogen is 7. The configuration of nitrogen is 1s2, 2s2, 2p3, 3s0, 3p0, 4s0, 3d0. The rule is what? The principal quantum number for last electron enters and the next d orbital principal quantum number should be equal. The principal quantum number for the last electrons enters into the 2p orbital. Okay, the next d orbital is 3d. So here the principal quantum number is 2. The next d orbital principal quantum number is 3. It is not equal, means principal quantum number for last electron is 2. The next d orbital principal quantum number is 3. Both are not equal, so it has no vacant d orbital, so it is not acts as electrophile, means Lewis acid. So next one is Lewis base. The central atom containing lone pairs like nitrogen, oxygen. Examples for containing lone pairs molecules: water, NH3, alcohol, amines, etc. All anions containing molecules acts as base, Lewis base, chlorine, Cl minus, H minus, F minus, etc. If take what is Lewis acid? Acid is an electron pair acceptor. Base is an electron pair donor. See, if take one example, H2O plus NH3 is equals to OH minus plus NH4 plus. Okay. See, nitrogen has electron pair, and H2O, H plus and OH minus. See, nitrogen has electron pair donor, and H plus is electron pair acceptor. It forms NH4 plus. It is called Lewis acid base concept. Okay. Types of oxides. Basic oxides means metal oxides acts as basic oxides like sodium, magnesium oxides, and some D block elements with lowest oxidation state, manganese oxide, chromium oxide, etc. Acidic oxides. Non-metal oxides acts as acidic oxides, like suppose carbon, nitrogen, oxygen, sulfur, phosphorus. These acts and etc. These acts as non-metal oxides. It forms means it acts as acidic oxides. See, neutral oxides. Before only we discussed non-metal oxides acts as acidic oxides, but carbon, hydrogen, nitrogen, these also acts as it is also non-metals, right? It forms It also non-metal oxides, but why it is not acting as acidic oxides, we may get doubt, but these are exceptions for non-metal acidic oxides. So it is these four acts as neutral oxides. Now amphoteric oxides. Metal, it reacts with HCl as well as with the base. It releases hydrogen gas, so it acts as amphoteric oxides. So the beryllium, aluminum, zinc, lead, tin, these are the examples. These oxides are the examples for the amphoteric oxides. 5 beryllium, aluminum, like oxides. A simple trick to remember amphoteric oxides: bell gelatin. B means beryllium, L means aluminum, Jd means zinc, L means lead, tin means tin. If this, remember, simple trick to remember this amphoteric oxides. If one example I will show you. Which of the following oxides is amphoteric character? See, calcium oxide, carbon dioxide, silicon dioxide, SnO2. See, now only we discussed SnO2 is the amphoteric oxide. And which of the following oxides has highest acidic character? See, CO2, the oxidation state is oxygen is -2, -2 plus -4. The carbon is +4 oxidation state, and the Cl2O4, 2x equals to the -2 is 7 into 2 is equals to 4, and x is 7. Higher SiO2 for 4 oxidation state. See, higher higher the oxidation state is directly proportional to acidic character. So Cl2O7 is the highest acidic character. That's all for today. Thank you for watching.